So we're continuing our notes for section 2.7. So this is the second half of notes 2.7, graphing techniques, and we're talking about some more transformations. Up to this point, our transformations, and we're on page 2. Up to this point, our transformations have been stretching or shrinking in the vertical or horizontal direction, or flipping. Reflecting, if you will, across the y-axis, or reflecting or flipping across the x-axis. All right, so we're going to go into some more types of transformations now. So we're going to start with a parent function, which is just the square root of x. We saw this one when we were playing around with Desmos. So what you might want to do is pause the video and go to Desmos and play around with some of these. Put in the parent function and then put these in and kind of see what happens to them. And then come back and look at sort of the rest of this video. I'm not going to open up Desmos. I'm going to assume that some of us probably can get away without looking at Desmos. But if you feel the need, go ahead and open up Desmos and type these functions in and sort of play around with what happens to the parent function when you do these transformations. Okay, so I'm going to just plot this function, f of x equals x squared. So I go over 1, up 1. I go over 2. I'm going to go up 1, 2, 3, 4. From the vertex, if I go over 3, then I go up 9. And generally, you kind of want to just fill the space with the graph. So make, points at all these. And again, make the points kind of big so that when you draw your curve through it, you're not obliterating your points. You want to be able to see, I want to be able to see clearly where you put your points. So in sketch in your parabola, like that. And then, arrows on the end, always good too, to indicate that it goes on forever. Okay, so when we put in, instead of just x squared, we have x minus 2, well, that shifts it. So if you think about it, let's just try a couple points. If I put a 0 in, that's negative 2. And negative 2 squared is 4, so that'll be up here. If I put a positive 1 in, positive 1 squared is 1, and so if I put a 1 in, I should get a 1 out. All right, and if I put a 2 in, notice 2 minus 2 is 0, so that's this point here. You can see that's going to be our vertex. You can kind of see the shape. You can see that the point we plotted here is really this one, then we plot at this point, then we plot at that point. Okay, so the think about what x value makes that 0, that will give us the vertex, or 2, an x value of 2 would make that 0, so that invariably will be our vertex. So if I think about it, so what's happening is that this whole thing is just shifting right to. All right, so once I know where the vertex is, then it's pretty easy. I go over 1, up 1. I go to the left and go up 1. I go to the right 2, I go up 4. I go to the left 2, I go up 4. So you can kind of build this parabola based on the same kind of ideas. Where we started at this vertex, what did we do? We went over 1, up 1, over 2, up 4, over 3, up 9. So we're doing the same thing here. And so I can go over 3 from the vertex, over to 5, and I go up 9, and the same thing here. So you just build that. Unlike the last transformations where we were putting numbers in front, or numbers in front of the x or in front of the function, here I know that this basic parabola is the same shape. This parabola shape and this parabola shape are the same because we haven't changed the coefficient out in front. So what these transformations are doing is just translating them. So this one is translating to the right 2. All right, let's think about what happens to this function when we put a plus 2 at the end. Well, that's going to raise it up 2. So our vertex, instead of 0, 0, is going to be 0, 2. That plus 2 adds the 2 points two values to every y coordinate here. So it just shifts it up 2. So we have this, and then from the vertex I go over 2, up 4. 1, 2, 3, 4, and I'm the same over here. Now I can't really fit my my next point up here, so I'll just kind of stop there and draw in our parabola. Okay, and of course arrows at the end are always good. All right, and then let's think about this one. So now we're doing both things. We're doing something to the x inside the parentheses, and then we're also doing something outside the parentheses. So think about it. This 1 is going to shift it left and right. Again, the opposite of what you think. So we're actually, instead of the vertex being at 0, 0, we're shifting to the left 1, and that -2 means we're shifting down 2. So our vertex is now here. And then, you know, again, there's no coefficient out in front, so it's the same shape as this. So from the vertex, I go over 1, up 1 in both directions. I go over 2, up 4, 1, 2, 3, 4, and over here as well. I go over 3, and I go up 9 to here. And again, on this side as well. Okay, and then just sketch those in. And of course arrows. Okay, so you can see that the shape of these 4 are all the same. The transformations here are not shrinking, stretching, or anything like that. Instead, the transformation is what we call translation. So it just shifted to the right, it shifted up, it shifted to the left and down. Okay, next one is an absolute value. Number 5 is an absolute value function. So this is starts at the origin, and we have a slope on this side of 1. Oh, kind of missing. Probably good to plot a couple of points as guides. All right, so it goes through all those corners. Slope of 1, and then over here goes through these corners. Again, it'd be probably good just to fill the space, the graph paper, with as much as we can fit in there. Okay, so it looks like that. Slope of 1, slope of -1. All right, so now let's think these are going to work the same way, right? So +2 inside, that's going to shift left and right, the opposite of what you think. I mean, at first you might say, oh, it's going to shift to the right too, but no, it shifts to the left too. So it's here. And then the slopes are still, see if I can go through those corners. Slopes are still 1 and -1. Okay. All right, this one is shifting left and right and up and down. So where's that vertex from the origin? We're shifting to the right 3 and up 2. 1, 2. So our vertex is now here, and we can just draw in our lines. Let's see, this one through each of those corners. You know, probably good to make little dots as you go along. That one's a little wonky, but all right. And then the last one, the vertex goes to the right 2 and down 1. So it goes through all these corner points. Again, I'm sort of missing it a little bit there. And then goes through these corner points as well. Okay? So these are all sort of translations, lefts and rights. And so let's talk about how on page 3, let's kind of come up with our defining rules then on page 3. All right, so vertical translations. Given a function g, defined as g of x equals some original parent function plus c. So in other words, if I take the parent function and I add c to it, I create some new function g of x. So g is simply a vertical translation of the function f. For every point x, y on the graph of f, there will be a corresponding point x comma y plus x, y plus c. on the graph of g, right? So the new function g is going to take the old function f and just essentially add it. So if c, the thing we're adding, is greater than 0 or positive, then this is simply a translation up the amount of up c amount. Okay? If it's less than, if c is less than 0, so we're actually subtracting, right? We're adding a negative, then it's going to be, we're going down. And then we say we go down like c, but c is negative, so that means we'd be going up. So we say absolute value. We go down the magnitude of c if c were negative. All right, and then horizontally, same kind of thing. If we have f of x minus c, and that's going to be the new that's going to be a new function g, then let's talk about what happens. So if c is greater than 0, then this is going to be a translation. If it's greater than 0, and there's a remember we have a negative in here, right? So if c is positive, it's going to be x minus a positive number, and that's a translation to the right. All right, it sounds like we're doing it wrong, but the negative is already in the formula. So if we're subtracting c, that means we actually go to the right. And then if c is negative, then that means we'd really have x minus a negative. So we would write that as x plus the value. And that's when we're going to go to the left. So that's why if you first look at these, they look like they're backwards, but they're not. Okay. So do the following graphs translate left or right from the perspective of the parent? So if we're looking at the parent function, what would do with this? So this one translates to the right 5. All right, and do the rest of these. Say, how much they're going up, how much they're going down, or, left or right, up or down. All right, so this one is plus 2, so that means it's going left 2, and then this plus 1 says it's going to go up 1. So the vertex, or that key component that we start with at the origin, is going to go to the left 2 and up 1. All right, this one. Now this one's a square root function, which generally kind of looks like that, right? It's a half of a sideways parabola. So this center point, or not center point, but the vertex of the half parabola, what's going to happen to it? So it's x minus 1 inside, so it's going to go right 1, and that negative 2 means it's going to go down 2. We'll see an example of square root translation down here. All right, and then this last one, plus 3, what's that going to do? All right, it's going to go left 3, the vertex, instead of being at the origin, it's going to shift over to the left 3, and it's going to go up 2. All right, so now let's use those ideas and, in everything. So now we also have some negatives in front too. So it's not just a translation left to right, up and down. It's also going to be maybe some shrinking or stretching as well. So, pause the video and graph this function. All right, so this is going to be a quadratic, which is basically a parabola. And so instead of the origin, think about what's happening here. So we have a negative x minus 1, so that means we're going to go positive 1, and then up 4, 1, 2, 3, 4. And then the negative in front means that we're actually not opening this parabola up this way, but instead we're switching it down and going down. So, but it's a 1 in front, right? There's no 2, or it's not shrinking or stretching. This one's just flipping. So instead of it being above it, it's now below the vertex. And so let's just plot our points. Go over 1, down 1, over 2, 1, 2, 3, down 4. And then over 3, down 5, 6, 7, 8, 9. Okay, so sketch that one in. Okay, so an upside down parabola, its basic shape, it's still over 1 down 1, over 2 down 4, over 3 down 9. Still the basic shape is just opening up down because of that negative. All right, this one then. So if you're not really sure, you can certainly always just plot some points, right? I mean, that's possible. But if we really want to think about this one, at first it looks like we're going to shift over 4. But this one's kind of sneaky because there's a 2, there's a 2 in front and there. So we could really almost think about factoring a 2 out of this. Right? Or another way of looking at it too is what x value makes this 0 in here. So I think you can see that it is a 2, an x value of 2 would make that 0, and that always gives us our x coordinate of the vertex. So that if you put in, if that's 0, then that would also be 0, right? I mean, like if I put a 2 in for x, this would all be 0. So that means at 2, 0, that's my vertex. Okay, does that make sense? But if we think of it in this way where the 2's out in front, then that means that's a stretch in the vertical direction. Does that make sense? So that means we're going to be over 1, instead of being over 1, up 1, over 2, up 2, over 3, up 3, we're going to go over 1, up 2, over 2, up 4. All right, and then in the negative direction as well. So it's just, and to confirm that, you can always put in a couple values. Like you could certainly put a 0 in for this and see what the y-intercept is. So a 0 in for this would be -2, absolute value of -2. Put a 0 in for this, that's 0 minus 4, absolute value of -4 is 4. So you can confirm that that point is valid, just sort of as a check. All right, next one. So this one, the parent, we had some square roots in the previous examples. So, the parent would look like this. I'm doing it lightly, right? That's what just the square root of x function looks like. You go over 1, up 1, over 4, up 2. So it's kind of a sideways parabola. So that's what the parent looks like. Now let's think about what's happening with the vertex. So the vertex is going to the left 2 and then down 3. So the vertex is now here. And then what's the 1/2 out in front do? It shrinks it in the vertical direction from this key point that was on the origin, right? So now instead of going over 1, up 1, I'm going to go over 1, up 1/2. Going up half as much because of that 1/2 out in front. So that's a shrinking, right? So I go over 1, 2, 3, 4. Normally I would go up 2. I'm going to go up 1. All right. And then we would go over 9, up 3/2, but I don't think we have the space for that. 1, 2, 3, 4, 5, 6, 7, 8, 9. It would kind of be over here, up 3/2, but let's not include that one. So you can see it is shrinking in the x in the vertical direction, in the y direction. All right, next one. So this one's an absolute value one, right? And so here's the vertex to start with. We're going to shift over 3. And there is no vertical shift, so it's at -3, 0. And then the -2 means instead of opening it up, it's flipping and going upside down and going to get more steep. So the slope is going to be -2 and 2. And again, if you weren't sure about this, you can always plug in a point to verify that. Looks like it would cross the y-axis where, like here. So that would be 1, 2, 3, 4, 5, 6. So if we put a 0 in, Sure enough, we would get -6. So that seems to be right, just, as a check. All right, and then the next one, the parent function, is sort of a wacky thing. It's like a piecewise function, just made up a couple different things. But what's important is if you look at some key points. So this is sort of part of a parabola, it looks like. And this is also sort of part of a parabola, it looks like. So let's think about what happens to this parent function if we do this, right? If we subtract 3 from the function, this whole thing is just going to go down 3. So start with one point at a time. I don't know, let's start with, I guess, the point that was at 0, 1. Now it's going down 3. 1, 2, 3. So that key point is now here. And then what we can do, that was this point, right? We can build the rest of it off of that. So how did we get from here back to there? We went up 2 and to the left 2. So up 2 to the left 2. That's this key point here. And then this one is just straight across from it. It's here. This one is down 1. Actually, it looks like 1, 2.5. So go down 1, 2.5 over 1. And from our key point here, how would we get to this one? We go down 1 over 3, down 1 over 3. So we aren't changing the shape of this thing. It should have the same general shape, but it just translated down. Okay. All right, now think about what this one's doing to the parent. It's moving both horizontally and vertically. So it's going to shift to the right 2 and up 1. So let's start with this 1 as our key point. It was here. And we're going to shift to the right 2 and up 1. So that's this point. Again, we're not changing the shape of the thing because there's no coefficients in front. We're keeping them sort of the same basic shape. So I'm going to go up 2 and to the right 2. That's this point at the peak here. And then this point should be down 2 and to the left 2. And then we're going down 2.5 and 1 over. And then we could go from that point to the next one, up 1.5, and then over 2 from there. So here. And again, just kind of sketch in what seems to be a parabola here, and a curved parabola here too. Okay? And now this last one, f of negative x. What's going to happen to this thing to generate that? So the negative x, we're going to do a reflection. This time we're reflecting about the y-axis because it's the negative inside. So the point on the axis, this one, that stays the same. But instead of going up 2 to the left, now we're going to go to the right. So this is kind of our parabola part over here. This one's down 1, 2.5 over 1. It's here. So this parabola continues down over here. And then we want to go up 1.5 over 2. So we draw that part. So it's a reflection of this thing across the y-axis. Okay, so that's kind of a combination of so sometimes we'll give you just a generic function and we won't actually give you a parent. So we give you sort of like a quadratic, and this is the parent function would be absolute value of x. This parent function we saw was the square root of x, absolute value of x. So we should know what the parent functions for these look like. This one's sort of not a generic quadratic or absolute value, but they give us a piecewise function. We should still be able to look at how they're transforming it and how to draw the new one based on the parent that they gave us. Okay, so you should be able to kind of do both those things. All right, so this is homework 272, the second part of section 2.7. This is the homework and it is due next class.